Thank you, Pat. It's my pleasure to be here and for the second year and present AEROSOURCE. And today I'll focus on the long-term trends, as Pat already mentioned. And I don't need, I guess, to introduce. We heard a lot of how particulate matter or PM affects, or air pollution in general affects health. So I'll skip that introductory slide. But I still wanted to reiterate on how policies do work. So we have an example there, how the smoky coal ban in Dublin resulted in the significant reduction in black carbon concentrations in the ambient air. Similarly, end of tailpipe emission regulations, filters, has reduced emissions of sulfur in all Europe, not just Ireland. That was followed by significant reduction in the ambient concentrations of the sulfur at the bottom. But that has left us with the situation that now PM is dominated by the carbonaceous matter, which means organic and black carbon combined. And again, that's not only in Ireland, that's all over Europe and the world, that now we have problems with organic matter, and it's much more complicated to resolve the sources of that organic matter. For this, we need sophisticated instrumentations like aerosol mass spectrometers that can measure PM, so the total concentrations, but also look at the speciation, including organic matter. So now with these instruments, we can see how those particles, what are they made of, but also to look at the main sources, where are they coming from. And we have a network, I guess the graphs are not very visible there, but we have a network of main 3 stations located in strategic places, like Mayhead on the west coast of Ireland, to look at the background marine particles effect on climate and the sources. We have one in Carson Point in southeast location to look at the long-range transport or the transport of pollution from the neighboring countries. And we have Dublin as the place to look at the local sources. There are also long-term measurements, running continuous measurements in Valencia in collaboration with methane, with the same instrument to look at the sources opposite to Carson Point on the other coast of Ireland, and many short-term measurements that we had for shorter periods in different locations to focus on specific cases. And just to point out that it's not only aerosol mass spectrometers that we have here, we have already a prototype of those super sites that were referred to in Thomas's talk this morning, that we have already measurements of the black carbon and the ultrafine particle number and distributions in those sites as well, to combine with the mass and provide much more detailed information on the particle properties and the sources. But just to go back and to say what we learned from the network, and we know in general that air pollution is coming from the local sources. In our case, it's mostly from the house heating, home heating emissions. That's our major local source now, even in the cities. And we also can have a transport of air pollution from the neighboring countries like UK and Europe. And there are different patterns. Like if we have local sources from the heating, the huge spikes occur in the evening hours and they die out in the morning and during the day, but they can reach really high concentrations comparable to China concentrations. While during long-range transport, the events happen for much longer period. It can be 3 to 4 days, depending on the air masses coming from Europe, but the concentrations are lower. So, and we have the differences in composition. While local events are dominated by organic matter, the long-range transport contributes a lot to the inorganic, like ammonium, sulfate, and nitrate. And before I proceed with the results, I just want to provide or to introduce you to a new term. It's not a regulatory term, but we wanted to come up with something that we could use instead of saying levels higher than WHO recommended thresholds for health. So we call them alarm days. So alarm days when 24-hour concentration of PM is higher than WHO levels, and the latest level, as we saw this morning, is 15 micrograms per cubic meter. I guess it's difficult to see on the graph, but anyway, so when I say alarm days, I mean when we have the levels higher than WHO recommendation. And since 2016, that's when we started measuring in Dublin, we observed 157 alarm days in total. So I will present some results showing the major sources for the alarm days, and that would be for those total alarm days. And we see a clear trend. So the yellow line over there, we see that we have much higher alarm days during cold season, like in January, February, and December, and they reduce significantly during warm period. So during warm period, in contrast, we have like 3 to 4 days of the alarm days for the period that we measured. So in conclusion from that, we have polluted winters in Dublin, where over 80% of the pollution come from the local sources and from the domestic heating primarily. And relatively clean warm periods or warm summers, where we have only less than 20% of alarm days in that period. And we observe, like since 2016, I said that we have long-term measurements over there, we do observe a positive trends, or the negative trends, but in a positive way, that we see a reduction in those alarm days. So if in 2016 we were seeing like 31 days per year, now it dropped to 10 days in the latest measurement period of 2023. So we see that positive trend of reducing of those alarm days, or the days where the PM concentration is exceeding WHO recommendations for health. However, we still see that 8 of 10 days of alarm days in the last year, 2023, are still coming from the local sources. So these are caused by the local pollution in Ireland, or Dublin specifically. And it's not just that we want to separate like local versus regional or transport sources. We wanted to go into more details, and the instrument is capable of providing that. So, but we had to teach the instrument on how to separate different fuels, for example, how to separate coal from peat, or even the processed fuels or the manufactured fuels, the biomass fuels, when you burn them, and how to separate that signature in the ambient. So in collaboration with Cork and UCD, we've done a lot of burning ourselves, contributed to the pollution, but for the good purpose or the aim, in order to fingerprint those fuels, in order to know how they look like, and then attribute them, or attribute the ambient concentrations to those specific sources. And what we have there then, that if we still talk about the total solid fuels, we see that year after year after year, we still see that solid fuel is the single highest contributor to the PM concentrations in Dublin. And even in the latest period that we have, 2023, solid fuel is still the dominant or largest single contributor to the PM. And if you look into specific fuels, as I said, we can look into different fuel contributions, not the total solid fuels combined. And again, I guess it would be difficult for you to see separate, but the green is peat. And even though we see a reduction in the contribution from the peat over the years, peat is still the major component of the solid fuels in Dublin. Again, so it's not only small towns that this pollution or the problem is relevant and acute. Even in Dublin, in the big city, peat and solid fuels are still contributing to the air pollution. We also observe changes in the fuels. For example, contribution from sulfates as I said, we can look at the chemical speciation of the particles, we see that the contribution of sulfates is increasing. And that shows us that the contribution from sulfur is increasing. And even though the maybe fractional contribution is not large, but if we compare the events, extreme events, when we have really high concentrations of the PM in the ambient air, we see that before 2022 or 2016, early 22, we had like 2 events with the sulfur in Dublin. While after late 2022, with the energy crisis and all the other consequences, we see the change in the pollution events, and we observe 8 strong sulfate events. So in less than 2 years, we exceeded the number of the events than we had for several years before. So it shows that the fuel composition in Dublin is changing, and it reflects the situation, economic situation, but also the energy situation and availability, and also, I guess, legislations in Ireland. So we have positive reduction in peat, but we see new fuels coming into picture that we need to separate now. So I've been talking about Dublin, and where local sources, as I said, dominate the PM concentration, and mostly residential heating and solid fuels with peat are the dominant contributors. If we go to Carson Point, which is, as I said, is on the southeast part of Ireland, that we can capture transport from the EU and UK, we still observe, even though Carson Point is relatively clean, we still see those alarm days happening over there, and they are above the WHO recommended 3 days per year. So they can be 7 or 8 days per year to 3 or 4 days per year. But we don't see that exciting trend as we saw in Dublin, a significant reduction in the number of those days. The situation in Carson Point is pretty stable. But the main difference from Dublin, another difference, is that the main contributor to those alarm days now is the long-range transport or the regional transport from neighboring countries. So that points that depending on the location, we need to think how we tackle those exceedances or the alarm days, whether it's local so that we can have better impact, or whether we need to collaborate with our partners in Europe in order to tackle those emissions. So the overall take-home messages are like that carbonaceous compounds, as I said, organics and black carbon combined are the dominant contributors still to the PM mass. So we have the PM dominated by organic carbon. And despite the improvements, very positive improvements in reduction in those alarm days, reduction in the extreme events, the number of the events and the concentration that we see during extreme events, solid fuel is still the single dominant source of the PM in Dublin. But regional sources are important in the more background locations like Carson Point, and that underlines the need for cooperative air quality measures across the Europe. And sources responsible for the poor air quality can vary with time, as I showed with the change in sulfate contribution. So we need a continuous monitoring in order to understand how fuel contributions changes and which policies do work and where we need to put more effort. And just, I'm over time, but just very quickly, that keep an eye on our other projects that we have, again, in collaboration with UCC and UCD that focuses on the ship emissions contribution to PM, or town air, that we will bring our equipment to the medium to small towns in Ireland and compare whether the same sources, or now we expect that it would be different sources that we see in Dublin. So town air poster is outside in the lobby if you want to know more details. Also, Solid Air will look at the new fingerprints of the new fuels that we see in Ireland, and the emission factors. And finally, EpiCare, funded by Research Ireland, will look at the health effects, not just emission, the mass, but also the toxicity of those particles. And I want, last but not least, to thank my team who all contributed to all these results.